Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve the system of equations x cubed plus y cubed equals -2 and 1 over x plus 1 over y equals 1. Alright, let's get started. From the second equation, if we multiply xy, we obtain x plus y equals xy. Let's call this equation 3. Now let's take a look at equation 1, which can be written as x plus y cubed minus 3xy times x plus y equals -2. Using the result of equation 3, we can change x plus y into xy, so xy cubed minus 3xy squared, so this plus 2 is equal to 0. This is the cubic equation of xy. Notice that xy equals 1 satisfies the equation. That means we have xy minus 1 as a factor, and if we do the division, we obtain the quotient xy squared minus 2xy minus 2 is equal to 0. When this part is 0, we have xy equals 1, and when this part is 0, then by quadratic formula, we obtain xy equals 1 plus minus square root of 3. Therefore, from equation 3, which is that x plus y is equal to xy, we have x plus y, xy is equal to 1, 1, and 1 plus minus square root of 3, 1 plus minus square root of 3. And we use the famous method of finding x and y when the values of x plus y and xy are given. That is, x and y are roots of the quadratic equation t squared minus x plus y times t plus xy equals 0. As can be seen from here, we have three different cases. First, when x plus y equals 1 and xy equals 1, x and y are roots of the quadratic equation t squared minus t plus 1 is equal to 0. This gives t is equal to 1 plus minus square root of 3 times imaginary unit I divided by 2, which means that x and y are 1 plus minus square root of 3i divided by 2, 1 minus plus square root of 3i divided by 2. Next, when x plus y is equal to 1 plus square root of 3 and xy is equal to 1 plus square root of 3, then x and y are roots of the quadratic equation t squared minus 1 plus square root of 3t plus 1 plus square root of 3 equals 0. In order to find t, we apply the quadratic formula, which gives t is equal to 1 plus square root of 3 plus minus square root of 1 plus square root of 3 squared minus 4 times 1 plus square root of 3 divided by 2. So we have 1 plus square root of 3 plus minus square root of, this part gives 4 plus 2 square root of 3, and this part gives minus 4 square root of 3. So we have 1 plus square root of 3 plus minus square root of minus 2 square root of 3 divided by 2. And this 2 square root of 3 is equal to square root of 12. So we have negative square root of 12 here. So inside this radical, we have minus sign and then square root of 12, or more precisely, positive square root of 12. And whenever we have minus some positive number inside the radical, we can write this as square root of that positive number, in this case positive square root of 12, times imaginary unit I. Here the double radical part can be written as fourth root of 12, so this times imaginary unit I divided by 2. Here I have to briefly explain this notation, 12 inside the fourth root radical notation, since many people get confused by what this means. You see, there are 4 complex number values satisfying the quartic equation z raised to the 4th power equals 12. Among these 4 values, This notation only refers to the positive real number, which is approximately this value. Why? Because that's how this number is defined. That's the promise among mathematicians. So with this settled, we can write the roots. X, y equals 1 plus square root of 3 plus minus 4th root of 12 times I over 2, 1 plus square root of 3 minus plus 4th root of 12 I over 2. And lastly, when x plus y equals 1 minus square root of 3 and xy equals 1 minus square root of 3, x and y are roots of t squared minus 1 minus square root of 3t plus 1 minus square root of 3 equals 0. So using the quadratic formula again, t equals 1 minus square root of 3 plus minus square root of 1 minus square root of 3 squared minus 4 times 1 minus square root of 3 divided by 2. So we have 1 minus square root of 3 plus minus square root of, this part is equal to 4 minus 2 square root of 3, and this part is equal to minus 4 plus 4 square root of 3, and over 2. So we have 1 minus square root of 3 plus minus square root of 2 square root of 3 divided by 2. So we have 1 minus square root of 3 plus minus, and we know that next part can be written as 4th root radical of 12, which means that x, y is equal to 1 minus square root of 3 plus minus 4th root of 12 over 2, 1 minus square root of 3 minus plus 4th root of 12 over 2. So from cases 1 to 3, the roots are 1 plus minus square root of 3i over 2, 1 minus plus square root of 3i over 2, 1 plus square root of 3 plus minus 4th root of 12i over 2, 1 plus square root of 3 minus plus 4th root of 12i over 2, and 1 minus square root of 3 plus minus 4th root of 12 over 2, 1 minus square root of 3 minus plus 4th root of 12 over 2. So we have 6 pairs of roots. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.